This is part 2 of lesson 4.4 on composition of functions. Okay, example set 4, application. Mr. Wilkie is thinking about investing his money so he can start saving for retirement. As he was doing his research, he discovered that West National Bank, we'll call it WNB, pays $80 if you invest your money with them for a year. Provo First Bank, we'll call it PFB, pays 7.8% of your investment if you invest with them for a year. That shouldn't be there. Okay, number 13, it says write a function, W of x, that models the money he would have after investing with West National Bank for 1 year. So how do we write an equation for what he's going to save? We don't know how much he starts with, right? So we'll call that x. But he does get $80, so we're going to just add $80 to it. And that's how much money he has after a year. So we're going to call that W of x. That means the function of West Bank in terms of x being our input. And so if he invests $1,000, he would do 1,000 plus 80, and that's how much money he would have. Okay, number 14, write a function P of x, so this is for Provo Bank, that models the money he would have from investing with them for 1 year. So now this one's different because it pays a percentage, and so this is exponential. And so if you remember how, it doesn't say anything about compounding interest. So what it's going to be, it's just going to be, you're going to start with your principal, which is x, and you're going to multiply it by, you get to keep that much, so it's 1 plus, and then the 0.078. Remember doing that because we have the 7.8%, and you get to add that to the 100% of what you put in, and that's your interest. And then it's going to be for 1 year, so like that. So anything to the 1 power is just 1. So really what I have is I have 1.078 times x. And that's my P of x. So if he invests it for 1 year, he would just do 1.078 times however much he's putting in, and that would be how much money he gets. Now for number 15, it says write a composition of functions. So a composition is where we put these together and they work together. That models the money that you would have by investing for a year in West National Bank and then taking them out and putting them into Provo Bank. So what we're going to do is we're going to start with West, and that's how much he's going to have in West, and then he's going to take it out. And he's going to put that into P of x. So I'm doing P of W of x. So we're going to take the W of x and put it into P. So this is my W of x. Maybe I should make that blue. The W of x right there, that part, is going to be the x plus 80. And I'm going to insert that into P. So here's my P of x right there. And where is x? Right there. We're right there. So I'm going to say 1.078 times x. And that's going to be P of W of x. And we can just leave it like that because that, even though, we could distribute it and simplify it, but that's fine. We're just going to write it like that. That's just fine. Okay, next we're going to learn about inverses of functions. In order to take us into that exercise and how inverses work and what they are, first we're going to do this little activity. And so it's very important on this that you get a ruler, straight edge, because you're going to need a very sharp pencil and a very straight edge to do this and to understand what's happening. So the first thing I want you to do is I want you to use black to graph the line y equals x. So remember that's y equals 1x plus 0. And so I want you to graph that in your graph right here. Again, use a straight edge and a sharp pencil. And then come back here when you've got that done. Okay, I enlarged this and brought it in a little bit so that we could see it a little bit more closely. But the next thing we're going to do is we're going to have 2 colors. So I'm going to use color 1 and then color 2. And for number 17, I'm going to graph these 2 order pairs. So I'm going to, graph 1, 2 in green, and I'll graph 2, 1 in red. And so you do that on your paper. So when I graph 1, 2, and then I'm going to graph 2, 1. I wish I had the ability on this to zoom in, but I can't. So that's why it's really important you get a sharp picture. Okay, now for number 18, I'm going to graph in green positive 3, negative 2. And then in red, I'm going to graph negative 2, positive 3. Number 19, I'll graph in green 4, negative 3. And then in red, I'll graph negative 3, positive 4. Okay, now if you just look at this image, look right there. What do you notice about it? Did you maybe notice a pattern of the points that you were graphing? Like with the ordered pairs? If you look at the picture of it, what if you were to fold on that line? You would notice that all of the red points are reflections of all of the green points. Okay, so if you folded, then it would be reflected across that line. Okay, now I don't want you to connect these after all. Sorry, I shouldn't have written that on there. But the next thing on number 20, what I want you to do is I want you to graph the line y equals 2x. I'm going to do that in green, so it's going to have an intercept of 0 and go up 2 over 1. So I'm going to graph this line. Again, it's really important that we have a sharp pencil and a straight edge to work with here. I don't have a straight edge on this, so I'm going to do the best I can, but yours should look better. And then in my red, I'm going to go and graph that line. So y-intercept of 0 and a slope of 1/2. So you'll notice that the first point I get on both of them was the first point that I had graphed previously. Okay, now I want you to look at the red line and the green line, and how do they connect to each other, or how do they relate to each other? Again, if you folded on that line y equals x, do you notice that the red line and the green line would reflect? So like everything between these two, like it would reflect. Okay, so that's something that we're going to talk about here, and that's what we call an inverse. So when you have an inverse, what's going to happen is it's going to reflect across this line y equals x. It's always that line. That's what an inverse does, and it reflects it. Now, if you look at these two ordered pairs, 1, 2, and 2, 1, they just switched places. And that's what an inverse is. It's essentially like they're switching places. Now, you'll notice when you look at an equation, it's not quite like that. And so when we look at equations that are inverses of each other, it's not exactly like you just flip it or it's reciprocal. It's not quite that easy. And so we're going to talk about how you would find the inverse equation of another equation. So we're going to talk about all of that. Okay, so let's go into the steps to find the inverse of a function. So if we have a function or an equation that we want to find the inverse of, there's basically 3 steps. Number 1, you're going to replace your f of x with y. So if it says f of x equals something, you're going to replace that with a y. Step number 2, you're going to swap your x and y. So instead of x, you put y. Instead of y, you put x. And then step number 3, you're going to solve your new equation for y. And when you get that solved for y, that's your new inverse. And we write that as f negative 1 of x. So the negative 1 is like a little exponent. Okay, so what we're going to do is we're going to take the next few questions and we're going to find the inverses of each one. So number 22, it says find f negative 1 of x. And so that means we're going to use the function f of x and we're going to find the inverse of it. So what you're going to do first, I'm going to write f of x is equal to x. My first step is replace the f of x with y. Step number 2 is swap your x and y. Step number 3 is solve for y. Well, it's already solved for y. So that means that f negative 1 of x is equal to x. So sometimes it's its own inverse. It's kind of like if we go back to this picture right here, if I had a point that was that, since it's on the line of reflection, it's its own inverse, it's its own reflection. And so that's what we're seeing right there in that first equation. So that's kind of your basic one, and so we're going to see like how other ones work. So the next one's going to be a little bit harder. It says find g negative 1 of x. So I'm going to take this equation now. Let me use a different color. That equation. So I'm going to write g of x is equal to 2x plus 2. That's the first thing, just write it down. Okay, the first step is replace your f of x, or in this case g of x, with y. So we're going to write y equals 2x plus 2. Okay, step number 3 is swap your x and y. So x equals 2y plus 2. And step number 3 is to solve for y. So I'm going to subtract my 2, and then I'm going to solve for y. So I'm going to divide everything by 2. So y is equal to 1/2 x minus 1. That is my inverse. So up here above my table, let's write this. So I'm going to write f negative 1 of x equals x. This one, g negative 1 of x, is equal to 1/2 x minus 1. So you'll notice that if you compare g of x and its inverse, they're not like just find the reciprocal or anything like that. You've got other things to work with. And so these 3 steps, so step 1, step 2, and step 3, that's how you find the inverse. It's not just a matter of like get a reciprocal or change your y-intercept. It's much different than that. Okay, let's try the next one. H negative 1 of x. Okay, erase the other stuff so it's not in the way. So I'm going to take my h negative 1 of x, just copied it down. Okay, now the first step, remember, is I'm going to replace my h of x with y. My next step is to swap the x and the y. And now I'm going to solve for y. So I'll add 1. And now I'm going to multiply by 4. And remember, you multiply all of it by 4. So it's going to be 4x plus 4 equals y. So h negative 1 of x is equal to 4x plus 4. So if I come back up here, and I would write h negative 1 of x is equal to 4x plus 4, that's, I mean, they're kind of like related. You can say like 4 and 1 and 4, like they're inverses of each other. Is that always the case? I think so. And in the y-intercept, though, that's something that you can't really predict that one. So that's one that's kind of, you've got to go through the steps to find out for sure. So I want you to pause the video and I want you to find m negative 1, or the inverse of m of x, and then come up with what that is. Okay, what you should have done, m of x is equal to 2x, so you're going to write y equals 2x. Then you're going to swap your x and your y, and then you're going to solve for y. So divide everything by 2. So y is equal to 1/2 x, or x divided by 2. It's the same thing. And so y, actually not y right there, we're going to write m negative 1 of x is equal to 1/2 x. Next, we're going to see how this can be verified with graphing. So on the next problem, it says to graph g of x and g negative 1 of x. So I'm going to do that again in 2 different colors. Please make sure you're using a straight edge when you're doing graphing. You know, graphing by itself is pretty inaccurate. It's really hard to tell, and that's just because we're human and we don't make straight lines by ourselves usually. So you want to make sure that you're getting a straight edge, and sorry this isn't a good example because I can't do a straight edge on this, but if you don't have a straight line, it's really hard to see what it is that you're trying to see. And so get a straight edge and make sure you're doing your lines correctly and precisely. So we're graphing the inverse now. And so when you graph that, you know, if you were just glancing at it, you probably wouldn't think anything of it, but now that you know about the inverse idea, that's your line y equals x. And you'll notice that where these two graphs intersect, it's on that line. So that point, -2, -2, that is on the green line and it's on the red line. And so that's the point of reflection, or the point where the reflection is the same for both of them. Okay, let's do the same thing for h of x and the inverse of h of x. Graphing h of x, y-intercept, whoops, wrong color. Go ahead and pause the video and you graph both of these and make sure that you've got it right, and then see if you can see how they're reflecting across the line that they're supposed to. So I graphed both of my lines, and you know what they're supposed to do. And so it looks like they're doing it. And that's one way that you can tell that your inverse is really the inverse. And so graphically, and of course we know that graphing is not perfect, and we know that graphing can be a little inaccurate because we make lines that aren't always straight. But if you look at it graphically, you can at least say like, oh yeah, that looks like it's reflecting. Okay, but there are ways to prove it, and graphing is not a way to prove it, but we can actually prove that we have the inverse of a function. So in order to prove that you have an inverse of a function, what you do is you do f of the inverse. So in other words, you plug the inverse into the function itself, or the other way around, you plug the function into the inverse, and either way, you get x. And in order to prove it, you have to show that it works both ways. So prove using composition that your answer, the inverse of g, is really the inverse of g. Okay, so to prove it, the first thing I'm going to do is I'm going to take my inverse and I'm going to put it in place of x in my function. So putting that in there, 2 of that, and then plus 2. That's my 2x plus 2. And I'm going to see what that's equal to. So 2 times 1/2 x is 1x. 2 times -1 is -2, plus 2 equals x. Okay, that's not enough though. I haven't proven it altogether. So I'm going to do it one more time, but I'm going to go the other way around. So the other way around is I'm going to take this and I'm going to plug it in for x right there. So 1/2 of, and then 2x plus 2 minus 1. So half of 2x, half of 2 minus 1, that's proven. So I know for a fact that that is truly the inverse of g of x, and I know that I did it right. So in order to prove it, that's what you do. Okay, 27, we're going to use composition to prove the inverse of h. Okay, so remember what to do. You can pause the video and try and see if you remember how to do it based on what we just showed you. But here's how. You're going to take that, you're going to put it in for x right there. So 1/4, and then you're going to put the 4x plus 4 in for x, so 1/4 x minus 1. Don't forget that other part. So then you're going to distribute, or just simplify it. Whatever expression you happen to have, you're going to simplify it. And it should come out to be x. If it's not x, then it's not right. It's pretty simple. Then the other way, we're going to take this and we're going to put it right there. So I'm going to say 4 times and then 1/4 x minus 1 and then plus 4. So 4 times a 4th x, 4 times negative 1 plus 4 equals x. So I've proven that. Okay, for the very last part of this lesson, you can see I must have messed up somewhere because I skipped a couple of numbers. I don't know where it happened to 28 and 29. I'm guessing I cut them out and forgot to change the numbers. But anyway, so what we're going to do is we're going to do this g of h of x, and that's just another composition. And so when I remember doing this in school, I remember this was super hard for me. So one thing that always helped is if I did that. So I just wrote that function, except instead of x, I left parentheses. And then inside the parentheses, I put whatever that is. So h of x is 2x plus 2. That helped a lot for me to do it like that. So when you're going to simplify it now, so you do 1/2 times 2x, 1/2 times 2, and then minus the 2, so that comes out to x minus 1. So that's what g of h of x is in this case. Okay, now for 31, we're going to do it the other way around, h of g of x. So I'm going to take h of x, and I'm going to write h of x, except I'm going to put parentheses for the x, and then I'm going to take this part, I'm going to plug it in, so 1/2 x minus 2. And then I'm going to simplify that. So I'm going to have 2 times 1/2 x, 2 times negative 2, and then plus 2, so that's x minus 2. And that's h of g of x. So you can see that h of g of x is not the same as g of h of x. So they're not, these two are not inverses of each other, number one, because they're not equal to each other, but also they're not inverses of each other because they're not equal to x. So even if they were the same, there wouldn't be inverses if they're not equal to x. On the last couple questions, I think I misplaced these. So we've already talked about this and how you would use composition to prove it. You would just do g of g negative 1 of x, and we've already done that. So that's fine. And then we already talked about this part when we first did the graph on that part. So we don't have to worry about that. Okay, this wraps up the lesson. You should now be able to do your homework.